Well, hello again everybody. Now I'm afraid for those people that have tuned in today to expect to see another episode on the Stellar television restoration, well, I'm sorry to say we're not going to be doing that today, really for no other reason than I just haven't had a chance to look at it this week, just had too many different things going on. So I'm afraid today's video is just going to be TAT. And for those of you who don't know what that stands for, TAT stands for this and that. Well, although we may not be looking at the Stellar television, today's episode is very much television related for a number of reasons. So my week didn't go as planned. One of the things that happened is I had a very large and old CRT television made by Panasonic. Well, that decided to develop a fault in that it started switching itself on and off. Now, I was actually quite happy to have a go at repairing it, but my wife said no. She's been wanting to see the back of that television. You know, she's been carrying daggers for it for the last few years because it's a great big thing, it's a CRT, and she wants to be able to do things like watch YouTube and Netflix and all that kind of thing. Well, the old analogue television, it really just wasn't capable of doing that. So because she's gone ahead and bought a new TV, we've actually liberated various gizmos and things which are plugged into it. So I'm quite glad that I've actually got to keep these because these are maybe going to be useful to provide video sources for my 405 line TV in the future. We've got a video player which I don't know if we've even got any videotapes anymore, but we're going to have to try and put a videotape in that if we can find a tape and see if it still works. I've got no idea. Don't think it's been switched on for about 5 years. And we've also got is that Panasonic? Yeah, another Panasonic DVD player. Again, this probably hasn't been fired up in 5 or 6 years either, but I thought it would be useful to keep both of these because if I am going to be interested in analogue television in the future, I'm going to want to be able to generate some video footage, so we'll be able to do that with both the videotape and I guess the DVD recorder as well. Now we've also got one of these boxes on the top, and I don't know if you call these TiVos or something like this. I think it's some kind of recording device. Again, I don't watch a lot of television, so I've never even switched the thing on, but I believe it's got some kind of hard disk in it, so you can basically, it will suck in all the digital Freeview channels and it will also record them. And I think the reason that we bought this box was because the old CRT television was an analogue television, but this has a digital to analogue converter in it. So again, maybe this would be useful to keep so that if I want to watch modern programmes on my old 405 line television, it would be useful to keep that as well, because I don't think either of these two will you know, decode digital and Freeview and that kind of thing. But before we do that, I thought we could just take a look at this Teletest. So this is one of those late night eBay purchases, and what this is a pattern generator. So the idea of this is this will generate a very simple test card, and you will be able to display that test card on a television. And well, yes, we use it for setting up televisions and testing them. I guess these were used back in the day when the test card wasn't being transmitted. Now the reason that I've bought this is because, as you may have seen last time, I was using a standard converter to generate the old 405 line television format. Now one of the things that my standard converter doesn't do is, although it will generate test cards and you can load test cards into it, I wanted a test card where I could actually put up some vertical Grayscale bars, and I didn't have an easy way of doing that. Well, apparently this one does have some Grayscale bars on it, some vertical bars, and the other reason that I bought this is it's got a composite video output, so I can take that composite video output, I can feed it into my standard converter, and hopefully that should generate some vertical bars on the 405 line television. So that's why I went ahead and bought this. I bought this on eBay and the price of it was about £50. So let me clear the bench, let's have a quick look at this, plug it in, see if we can get it to do something. So here's our Teletest handheld TV pattern generator. Now I think these were maybe made at the end of the 80s, maybe in the 90s, I'm not exactly sure. You can see that the outer box is somewhat damaged, but at least it's actually got the box at its original packaging, so that's kind of useful, isn't it? Let's go ahead and open it up. Oh, and we're immediately presented with, well, we've got lots of gubbins going on in there. Let's just unpack this first and let's take a look. Now I'm sure some of you'll remember that I do have a couple of other pattern generators. I've got a Lab Gear one and a Cosa one. Well, the reason I bought this is I wanted something a little bit more modern, although unfortunately this one will only do the more modern standard, which was the 625 line televisions, rather than the 405 line that I've got. But hopefully what we can do is, even though we can't make use of the I'm going to say 500, 600, 700 megahertz RF output, because actually the old 405 line televisions, they actually use a different frequency. So we can't use the RF output, but hopefully we will be able to use this video 75 ohm output to feed into the standard converter. So take a look at the manual. It says it's made by Teletest. They call it a colour bar, grayscale, crosshatch and red purity, and the one that I'm most interested in is to be able to produce this grayscale, and I can see on the picture here, I can see the grayscale vertical lines. That's what I was interested in. Now it'll also generate a 1 kilohertz tone. It's got RF video, which as I say, probably the RF video won't be useful for me unless I'm working on a 625 line analog television. It's got RF audio. It's got line video and line audio. So I think by line, actually I would probably call that composite video. So it looks like it can be battery powered or mains powered via a PSU. And I did spot that, yes, it has been shipped with, well, it looks like the original PSU. Now we've got the manufacturer's name on the bottom here that looks as though it's Ozan, O-Z-A-N, Ozan, and they were at 37 Haviland Road, Ferndown Industrial Estate, Poole, Dorset, BH21 7SA, and we've even got a telephone number 0202 877 270. I wonder if Ozan is still going. I guess they won't be making analog pattern generators anymore, even if they are. So taking a look at the first page of the manual, we can see all the patterns that this pattern generator is capable of doing. So it says we can do colour bars, so the vertical bars are white, yellow, cyan, green, magenta, red and blue and black. The luminance content is 95%, which is the BBC specification, and the EBU or 100% specification are also available on request. So don't really know what that means. That's also showing what our video waveform would look like on an oscilloscope. So I would be quite interested to have a look at that. Now, my understanding is that the actual colour television standard, the PAL standard, is slightly different than what the old black and white standard will be. But I still think it would be useful to see that. Just looking at it here, underneath we've actually got the grayscale pattern here, which is more interesting to us. So you can actually see here that we've actually got these step ladders, this set of stairs here. Well, that corresponds to actually the colour bars, sorry, the grayscale bars. They're getting brighter. So at the top of the graph here, where it's high, that represents white, and where at the bottom here it represents black. And what you're actually seeing there, you're not seeing a whole picture, you're actually just seeing one line, I guess. So this is just one line of our 625 lines, but all the lines effectively are going to look the same if you're actually transmitting a grayscale with vertical bars. So the next thing it can actually generate is this crosshatch pattern. So it says the crosshatch has 17 horizontal and 23 vertical lines, with cancellation boxes around the edge of the picture showing the absolute limits of the TV signal. And the final pattern that this will generate is this red purity signal, and it just says the pattern consists of a red screen with no luminance contents from either of the other two primary colours. So again, I guess you use this for setting up something on a colour television, not exactly sure what, but this just looks like a plain raster. So I'm just guessing that on a black and white television this will just show up as maybe a grey screen. And the pattern generator will also produce this audio output. The audio generator provides 1 kilohertz nominal sine wave, and again we've got a picture of the sine wave there. On page 2 of the manual it shows that we've got these various connectors, and it looks as though one of them is the first one here is the RF output, then we've got the composite video output, and then I think we've also got the audio output, which was the 1 kilohertz sine wave, and I think we've got a selector switch that lets you select between either composite video or the actual RF modulated signal. And there's a piece of paper over the top that says that regarding the UHF channel information, this has been preset to channel 36. So taking a look at the front of the Teletest, I can immediately see here's a switch on the top that lets us select between the various patterns, which was red purity, crosshatch, grayscale or colour bars. And that's a little neat slider switch. We've got a battery 9-volt indicator, we've got a power switch. I seem to remember these power switches from back in the day. I think I used to buy these power switches from Maplin's, I certainly remember them. We've got the manufacturer's name, this Ozan, on it. And it's also got a picture here of, well again that's a colour waveform, isn't it, because it's got the colour burst symbol at the beginning of it, and it's also showing the 1 kHz sine wave underneath that. Apparently this was calibrated on 1st of the 3rd 1995, so yes, she's got a few turns on the coil. I'm guessing this connector here must be the external power supply. Turn it over. Oh, looks like the battery. Must be able to operate this off battery, but is the back missing? Nope. Okay, there's a back battery cover. Go on there. Okay. Oh, and here's this test adjustment. So the UHF signal is preset to channel 36, although to alter it you break the seal and use a small bladed screwdriver. So it looks as though somebody's actually been in here before us and maybe adjusted it from, I don't know, channel 36 to some other channel, so we'll have to find out what channel it's on. So of course, just like today, our Teletest came with some warranty card and well, nothing changes, so the warranty card also hasn't been filled in. I wonder if anyone anywhere has ever filled in and returned one of these warranty cards. I certainly don't think I have. I'm just wondering, shall we actually fill this in and post it off for a laugh, see if anything happens? I don't think it will somehow, will it? So I don't think that's any use anymore. Okay, so here's one of the wall wart power supplies, and just feeling it, it's relatively heavy, so it means that we've got an analog power supply, none of that horrible switch mode nonsense. And the power supply is 230 volt AC to 9 volts DC with a maximum output of 300 milliamps. So our pattern generator did also come with a couple of leads. This is what they call a SCART lead, isn't it? Again, I don't really know much about SCART leads, but it looks as though this SCART lead will actually break out some of the video signals. I think SCART leads were used for plugging in all the auxiliary equipment on televisions, weren't they? It was kind of like a common audio and video bus system, wasn't it? So you could plug in your video recorder and your DVD player, and then the SCART connector would plug into the back of the television somewhere. I don't think the modern TVs use these SCART video leads anymore. I think it's probably all done with HDMI or something like that. So it also comes with another SCART adapter which doesn't have any leads coming out of it, it just has some plugs on it. I can see here we've got the yellow one, which is the video, composite video, and we've also got, well, it says mono, we've got the left channel is a mono channel, and then we've got, well, that's white or red, which is just says audio right. So yeah, we've got a couple of connectors that must be the audio channel output, composite video, and I'm guessing that this allows you to maybe plug into either a television or a video and feed video information either into it or out of it. Maybe these things are plugged together. I'm guessing that they probably do something like that. So this will allow you maybe to set up the various types of or configuration of SCART leads. I'm guessing they must add some form of different genders to do with being inputs or outputs. Again, don't know much about SCART leads, not really my thing. So we'll put these on one side. Oh, and just finally we've got some what just look like, I'd just call these phono connectors of some description. So I'm guessing these allow you to I don't know, connect phono leads together. Yep, they do. So I'm guessing that all these leads and gizmos and things like that, these must have all been very useful to the mobile television repairman back in the day. Because of course pattern generators are nothing new. You've seen me using the Lab Gear one and the Cosa pattern generator on one of the previous videos. But I think the idea of these is that back in the day televisions probably weren't as reliable as they are now, and it seemed to be pretty much a full-time job of television repair people coming around your house and changing boards and I don't know, banging the top of it and, well, doing all the things that they had to do back in the day to make a television function. So of course you would have probably a mains operated pattern generator back at the workshop, but for field engineers and stuff like that, they wanted something a bit more smaller and a bit more portable. And I guess that one of the reasons that they were maybe using these is that, well, again, back in the day, television wasn't always broadcast, was it? It certainly wasn't broadcast during the daytime. I seem to remember it wasn't. You used to get a test card. But maybe if there wasn't a test card available, that's when this portable pattern generator was going to be used. And I think there is some rather special features of having things like crosshatch patterns or red purity or grayscales. Again, because I don't really know anything about setting televisions up yet, I'm sure that these had all very particular functions for when you were installing and repairing televisions. Well, I'm going to have to learn about them as we go on, aren't we? So I guess before we go any further, we're actually going to need a television. So I've actually got this National Commando 505 television. Now I think National was probably National Panasonic, wasn't it? It looks a little bit like the Panasonic symbol, so I'm guessing there was a tie up there. I think I bought this television a couple of years ago, so I think you might have seen it before. Now the reason that I actually bought this particular television was simply because it was very cheap on eBay and I didn't want to spend a lot of money at the time. So I bought this, I think it was about £20, something like that. And the other reason that I bought this particular television is because of its physical size. It is relatively small. We're all limited for space in the workshop, aren't we? So the reason I bought this is because I could just put it away in a cupboard or a wardrobe or something like that when we weren't using it. So yeah, it was cheap and it was small. So the next thing I'm going to plug in is a power supply for our teletester. Quite like the name of that, seems quite apt, doesn't it? Teletest. And because I don't know anything about this power supply, you never know, it might be faulty, it might have been in storage for 20 years. Better just check it's got an output. And make sure the output is a safe output. Don't want to end up putting 30 volts into this thing because it's designed to take 9 volts. So that is... ooh! That's actually a lot higher than I thought it would be. I think what we'll do is we'll just take a look inside this and well, see if we can see anything untoward. Okay, we're just taking a close look at our power supply. It looks as though it's not actually regulated. Although interestingly enough, I can actually see a placeholder here for well, I'm guessing it should have had a traditional linear regulator, something, I don't know, a 7809 or something like that. Well, it's actually got it's pinned out to take one, but it isn't fitted, and it's got a resistor missing here, which I'm guessing is probably just a voltage drop down resistor. Got another capacitor missing, C2, which I'm guessing was maybe a few hundred nanofarad or something to stop the regulator oscillating. But certainly for some reason they've actually chosen not to populate this power supply with a regulator, so I am somewhat surprised that they've done that. So obviously the people who actually manufactured this power supply did decide it would be fine to actually operate our Teletest unit with this 16 volt supply. Now my mains voltage tends to be a little bit high here, so that could be pushing it up, and of course I really wasn't putting very much load on it. Maybe it needs a few hundred milliamps load. And interestingly, I've just noticed the way that this actually assembles, in that we've got the mains connectors here on the plug socket, and they just press against the back of the circuit board there. So obviously important to get it the right way around. That would really ruin your day, wouldn't it, if you put this together the wrong way around. Well, before giving up on that power supply, let's just try putting a bit more load on it, see if it pulls down. So I've got I think this is an 180 ohm resistor here, so this is going to pull about 90 milliamps, isn't it? For some reason I think this Teletest, I'm sure it says somewhere in the manual that it takes around 300 milliamps, so let's see if it drags the voltage down a little bit when we put this load resistor on, and if it does, maybe it will be okay. So when we're drawing about 100 milliamps from it, or well 80 milliamps, it has pulled it down somewhat, so that's pulled it down to, well, where are we? 13 volts. So this says the maximum input is 12 volts. Let's just see if it does tell us in the manual what the current draw is of this. current consumption is approximately 120 milliamps. So I'm guessing that probably with 120 milliamps load on this power supply, it is actually going to pull the input down closer to 12 volts, which is what this needs. So I guess we're going to take the manufacturers at their word and assume that it's okay, because certainly there's no voltage regulator in here to go wrong, so I'm going to trust the original designers and assume that this is good. Famous last word. Should we have a go? Here we go. Okay, well it's switched on anyway, so there we go, we got a red light. Triumph. So I guess we just have to plug in the television to this RF output. Okay, that fits into there. Do we just tune in now? Oh, we got something. So that's the red purity test. So I'm guessing, according to the picture on here, that's just a blank raster. So we can have crosshatch. Oh, and there you go. We've got a crosshatch pattern. That's amazing, isn't it? So there's our crosshatch pattern. Next one it says it will do is grayscale. And we have in fact got a grayscale, starting off very black here and getting whiter and whiter. Maybe we've got a loose connection somewhere, I'm not sure. Yeah, I think the antenna connector's a bit loose or dirty. What else can we do? Turn the volume down a bit. You can hear the 1 kHz tone there, can't we? That's coming through. Now the final thing that we can do is colour bars. Now this isn't a colour television, but let's see what it does. Okay, so the colour bars just look like a bit of a reverse of that, don't they? Okay, so it certainly looks as though our pattern generator is it's working, isn't it? It's actually doing something. I think we might have a dirty switch on here somewhere, maybe. Of course, this probably hasn't been used for 20 years, so maybe the switch needs a bit of a clean or a wipe. But yeah, it's basically functioning. That looks quite good, doesn't it? I think maybe what we'll do next is I'd be interested to see what some of the video waveforms look like. Now, the output from this is a modulated output, and I've kind of calibrated this television so I can give you a rough guess at what this output frequency is, because I've put some marks on here. If I can just find the dot. Okay, so it looks as though the output of our teletest, it's in the 600 megahertz region. Well, unfortunately my oscilloscope's only got a 200 meg bandwidth, and although you can of course exceed the bandwidth of an oscilloscope, I don't think it's going to work at 600 megs. But one thing I think we can do is, rather than look at the modulated RF output, what we can do is we can look at the composite video output. So what we can see here is each one of these, I'm going to call these boxcars, each of these boxcars is one line. So we're not looking at a whole frame, we're not looking at a picture here, we're looking at one line. Now for a television, the higher the line is here, the brighter the signal. So this is giving us, oops, touch screens, don't you hate them? So this is giving us an output across the screen of uniform brightness from one side of the line to the other. So that from this side of the television screen to this side, it's all a uniform brightness. We may have to pan around along a little bit. But you can see all the lines of information. There's no difference in them at all. Now just something to point out here, you can actually see these negative going pulses. Well, what these are at the start of the line, and they actually tell the television it's going to take a new line, so I guess they're almost a bit like a carriage return on a keyboard or a typewriter, in that, well, it's actually at the start of the line, so this is actually going to tell the television to actually start to draw a new line, and that's a synchronization pulse which tells it to do that. So because these are line synchronization pulses, you'll also have some other type of synchronized pulses which they call frame pulses. Now we're not seeing any frame pulses, but frame pulses are a lot wider. I think they tend to be something like, I don't know, between 6 and 10 times the width of a line pulse. We just happen not to be seeing any there, but they would exist in the actual full video waveform. Okay, so I've gone back to the television picture now, and I'm going to actually select this grayscale, because what we should see when we select grayscale, we should actually see like a staircase effect, because the brightness is going to vary from one side of the screen to the other. So let me just switch that over now. So there we go, that's a grayscale. Switch back to the oscilloscope. and I'm going to capture a new bit of video. So taking a look at the television picture here, I can actually see the first bar is almost off the edge of the screen. So the first bar is black, then it's lighter grey, it gets lighter until I would call that probably maximum brightness there, full white. So it looks like we've got 1, 2, 3, 4, 5, 6, 7, 8 steps in brightness. So if we look at our video waveform here, we should see the same thing. So here's our black here, and then we've got 1, 2, 3, 4, 5, 6, 7, 8. So each of these steps here corresponds to one of these bars. But again, you're not seeing the whole picture here, we're just seeing one line. Okay, so you can see on the oscilloscope screen that we've actually captured some line pulses again. So there's one line, there's another line, there's a third line. Now interestingly enough, the way a television works is they don't actually send the lines in sequence, it actually sends the odd lines that make up the picture, and then it sends the even lines, and that's called interlacing. And the reason that televisions use this interlacing technique is to prevent flicker, because the frame rate is actually quite low. It's actually only 25 actually complete pictures every second, and the human eye would probably detect that as flickering. So what they do to try to trick the human eye, they actually send the picture in two halves. So they send all the odd lines, and then I think they send the even lines, and your brain actually merges the two pictures together and you see a picture without flicker. So here we're seeing maybe, I don't know, I'm going to say that maybe that's the first line, then the third line, then the fifth line, something like that. But what we're going to do is I'm going to look for some of the frame pulses now. Okay, so you can see I've zoomed out on the oscilloscope. So here is one complete interlaced picture. So it's half of the frame, if you like. So that one is maybe all the even lines, and then the next one along here could be all the odd lines. I'm not sure whether these lines are odd or even, I can't tell by looking. But what I did want to see here, you can see we've got a gap between the sets of lines here. So that's this frame pulse that I'm talking about. Now the reason that I think this 405 line television we've got, the reason I think the video picture is rolling, is because you have something inside a television called a frame oscillator, and basically the frame oscillator causes the dot on the screen, the cathode ray tube, it causes it to retrace at the end of the frame. It causes it to retrace and start again. I don't think that's working properly on my 405 line television. I think it's missing the frame pulses. Now inside the 405 line television, in fact any television, you've got a circuit called a sync separator, and the job of the sync separator is to differentiate between the pulses which are used to synchronize the line time base, which is that synchronized pulse there. So that's a line synchronization pulse, and this is a frame synchronization pulse. So it's the job of the sync separator within the television to actually be able to recognize both types of synchronization pulse. One of the types of pulses will go to the line oscillator, and this pulse here will go to the frame oscillator, and again it's used to stop our pictures from rolling. So this is one of the reasons why I wanted to take a look at the video waveforms today, because really if you don't understand what video waveforms look like, and I didn't understand what video waveforms look like before I started experimenting today, you know, it's very hard to diagnose things. So there we've just seen some frame pulses. So there's one frame, well there's one half frame, there's one half frame, so together they make up one full frame, and you can see the gap here, which is the frame synchronization there. That's this gap. Can we zoom in on that a little bit? Now interestingly enough, you can also see these little spikes. So although I actually called this this big gap here, although I actually called it a frame pulse is actually made up of a little of these kind of runty line pulses, and again that's so that the line oscillator in the television doesn't lose its lock. But you can actually see that there is effectively a gap between one frame starting and another. So again, it's the job of the sync separator to identify this gap and tell the television it's going to about to start a new frame worth of video. So just before we finish playing with our pattern generator, there's one feature of the video waveform that I haven't really talked about, and that's for a very simple reason that I don't really fully understand it. So this pattern generator is designed to work with colour televisions. So you can see here we've got this little, I don't know what you call it, this little pulse shape thing here. Let me just zoom in on one of those. Let's zoom in on that one. So what they call this thing here, they call this a colour burst signal, a colour burst pulse. Now this is actually only used on colour televisions. A black and white television will just ignore this this pulse here. Now I think that the colour burst signal, it's something to do with how a television can recover the colour information on a colour television. It isn't used on a black and white, it's just used on a colour. And I've got to admit, I don't really understand how this operates, but I just thought I would point it out. If you're wondering what that is, it's a colour burst.